So, welcome to our webinar, 4 ways telecoms are using GIS and location intelligence. Just to introduce ourselves, so I'm Helen McKenzie and I'm a geospatial advocate here at CARTO. So you probably are seeing my job title and not really knowing what on earth that means. It's basically I'm someone at CARTO who's here to get people really excited about location intelligence, whether they are a data analyst, data scientist, here to sort of get people excited about it, realize how easy and crucial it is to do. And Carmen, would you like to introduce yourself?
Yes, thank you, Helen. So hello, everybody. Thank you for coming to this webinar. I'm a solutions engineer at CARTO. As a background, I'm also a telecommunication engineer with experience in radio network planning, and I'm looking forward to show you later the demo.
Amazing. Thank you so much, Carmen. So here's what you've got to look forward to in the next sort of 45 minutes. First of all, we're going to talk to you a bit about what location intelligence is, in case it's a phrase that you haven't heard before, but also what is the value of it? Why is it something that you should care about? And then we're going to move on to location intelligence and spatial data science specifically for telcos, and then talk about CARTO in that sort of framework and how we help businesses in that area. And then finally, probably the reason why you're all here, Carmen's going to give you a bit of a demo and show you an example of how CARTO helps people solve those problems. So let's get going. First of all, what is location intelligence? So you might have heard of the phrase GIS, which is Geographic Information Systems, or geospatial or spatial data science. They're all sort of fairly synonymous. They're all about helping people and organizations extract insights, and particularly actionable insights, from location data. And that's what we're here to help people do. So we think that most organizations are really missing an opportunity. We think about 80% of data has a location component. I personally think it's far higher than that. I can barely think of a single data source that doesn't have some sort of location component. But we think about 10% of that businesses are using to power their decisions. So we think there's a huge gap in the insights that businesses are getting. So just to sort of help you understand what location intelligence is, we've come up with a bit of a problem that has 2 different ways of approaching it. One is with location intelligence and one is without. So the problem that we've come up with is, say that you work for a telco company and you're trying to work out if you need to improve broadband speeds in Washington, DC. So a way that you might do this, and this is a very simplistic approach considering we're here for about 40 minutes, so we're really simplifying this. So the approach here is that I'm going to investigate upload and download speeds in the district and see if what passes as good. So without location intelligence, I might do something like this. I might look at average upload and download speeds across DC. You can see here the download speed, which is the pink bars on the left, for DC is about 250 Mbps, and the upload speed is a lot lower, which is about 80 Mbps. And we can compare that to the bar chart on the right, which is what good is. So we can see that actually DC definitely passes for good if we're looking at it this way. We can see that the download speed is far higher and so is the upload speed. So the outcome from that might be, we actually don't think we need to worry about service improvement in Washington, DC. It looks fine. But actually, the picture is a bit more complicated than that. So what we've got here is the location element added into that analysis. So on the left, we can see the blue areas are deemed areas of poor download speed, and the pink areas are areas which are deemed to have a poor upload speed. So you can see that actually there's a lot of areas across the district that are really missing that really good broadband, which we all know is a huge problem. I probably, if I was in these areas, wouldn't be able to be giving this webinar right now. So we can see that the picture's actually a lot more complicated than just saying things are fine in DC. So the outcomes here are that DC actually probably could benefit with some targeted service improvements. So the next step might be to look at these areas where there's poor download speed and start to think about things like population and working population and footfall, and work out if these areas where actually needs a better service, so where actually could benefit the most from these broadband improvements. But you can actually see from these maps, I'd be really willing to bet downtown would be a great bet. It's quite shocking that the downtown areas are areas where the speeds are much lower. So spatial data science for telcos in particular, what's the sort of, how can it help? So first of all, here's just a few examples of the types of companies that are already thinking about location intelligence in the telco space. So Vodafone, BT, Telus, Orange, T-Mobile, lots of familiar names here. And there are lots of different spatial problems that telco businesses solve. Carmen, in a couple of minutes, will go into network monitoring and planning in a lot more detail, so I won't go into those too much right now. But just to sort of skim over these, give you a bit of an overview of how location intelligence can help feature here. So for network monitoring, the really key area is all about collaboration. Location intelligence is really helpful for helping field teams speak to operations teams, speak to customer-facing teams, really help with that collaboration and make sure everyone's on the same page and really shorten that time it takes to respond to things. And this is all about minimizing downtime, which we know is really key for customer satisfaction. Next, moving on to network planning. The really key thing here with location intelligence is location intelligence gives telcos much more intelligence behind their deployment objective. So it's all about de-risking growth. It's about making sure that any plans for growth are really well thought through, really evidence-based, really data-driven, and really, really targeted. This is really important for long-term planning, particularly making sure that capability building is really pinpointed to the right target markets. Our third use case in this area is geomarketing. So this is really, really helpful across a lot of different industries, and telco is no different. You might be familiar with walking down the street and getting a push notification telling you that you're within 5 minutes of a Starbucks or something like that. It's that sort of idea about making sure that people are being given really targeted geomarketing information to really, really personalize that for them. So this is all about making sure that products are really scaled and targeted to the right markets and being able to pivot this based on real-time data. And then our final use case here is smart cities and Internet of Things. So as people who I imagine most people here work at telco companies, you're probably familiar with the vast amount of data that telcos generate. It's absolutely huge, and it's not just necessarily related to things like broadband and Wi-Fi and all of those things. It can be much wider than that. And actually what a lot of telco companies are doing at the moment is thinking about data monetization, how that data that they are generating can be used to give insights to other companies and potentially monetizing that. And a big area this is really helpful for actually is smart cities and Internet of Things. Telco companies can often be generating data on things like road traffic or waste management, and being able to share that data with city administrators is really, really helpful and really, really valuable. And in turn, that unlocks a lot of value for people living in those areas. So one organization that really embodies a lot of these areas is Telus, and I'm just going to really quickly run through what they're doing in the geospatial space at the moment. Because they really embody so many of these things. So their real aim is all about modernizing their geospatial tech stack. Like I mentioned just now, so many organizations in the telco space just work with such vast amounts of data that it's really, really key that they're working with the most modern tech stacks to be able to unlock insights from those. It's also really important that Telus have a self-service, up-to-date analytics platform. And by self-service, what I mean is that the people who are making decisions and driving actions from this data aren't necessarily the people who are building these platforms and have the sort of data and technology skills to be able to build these. But it's important that they have their fingertips sort of on the data so they can really quickly make those decisions. So they do this in a wide range of ways, and there's loads of different benefits to this. One of which is that you can really seamlessly ingest and analyze a wide range of wireless network data streams directly from the cloud, so minimizing the need to export, transport, and load your data. You can integrate spatial analysis with existing software and tools like BigQuery Tiler. So something that's really important about CARTO that you'll see in a moment is just how interoperable it is and how good it is at interfacing with other tools. And finally, again, relating to big data, Telus are great with the solution at scaling their analysis and really quickly delivering rich coverage insights, which saves hours of time a week, which doesn't sound like a very big number, but actually when that scales up to loads of staff and across the whole year, the money savings are huge. So just quickly before we get on to the live demo, I'm just going to talk a bit about how CARTO in particular helps those businesses solve spatial problems. So CARTO, we like to position ourselves as a location intelligence platform. And you might be familiar with business intelligence platforms, so things like Tableau or Power BI, and they're really good at helping people understand where. So they help people understand questions like, where are there gaps in our customer base? The difference with CARTO, because we have so many more analytical tools available, is that we can help organizations really answer why. So not just saying, where are there gaps in our customer base, but why are there those gaps? So is this relating to things like infrastructure, services, demographics, marketing? Being able to really dig into those different things is incredibly helpful. So before CARTO, BC, data couldn't really be accessed on the cloud, particularly geospatial data. So organizations wanting to do spatial analysis needed to access this data via specialized platforms and databases, particularly desktop-based GIS software, which really limited doing location intelligence and spatial analytics to real specialists in that area. But at CARTO, we wanted to do something different. We really wanted to open that up to more people. So we are really keen on democratizing access to location intelligence. So it's not just people with a sort of traditional desktop GIS background who can use CARTO, but it's also people with more data science skills, maybe Python, maybe SQL, or maybe people with no real data background and who more want to use a sort of very easy to use point and click user interface. And really our mission with all of this is about to unlock the power of geospatial. So how does that fit in with Google and Google Cloud? Well, we describe CARTO as a spatial extension for BigQuery. So it's about enabling Google Cloud customers to unlock the power of spatial analysis and turn location data into business outcomes. Here's a little sneak peek of what you're going to be seeing later. And a bit more about how they sort of fit in together and how they interact. So there's quite a lot of information on this diagram, and I know everyone's probably keen to get on to seeing the maps. So I'll just point out the sort of key areas here, which is that BigQuery and CARTO interact really, really seamlessly. All of the work that you're doing in CARTO is actually happening within BigQuery. So when you're running SQL analysis, when you're using our analytics toolbox, you're running all of that within BigQuery. You don't have to take any of your data out and you don't have to put any data back in. It's all happening there natively. We'll be sharing these slides after the webinar, or you can come back and watch it again if you are more interested in this diagram, but there's a lot going on here, so I'll just move on. So what does CARTO actually offer people and where does it add value? There's sort of 5 pillars to what CARTO does and how it adds value. First of all, connectivity, and I just touched on this, but it connects to your cloud data warehouse and tools and the services you already are using to simplify your workflow. Secondly, premium data. So I don't know if people have seen this before, come across this, but we have a spatial data catalog, which has over 12,000 data sets in it. It's absolutely incredible. We basically have worked out that a lot of data scientists and data analysts are spending about 70% of their time sourcing and cleaning and formatting data, and that means they're not going to do the really fun stuff, the analysis and the visualization. So we try and create an area where people can access all the sort of commonly needed data, like things like demographics and administrative boundaries, all in one place to make that easier for them. And there's also loads of other really cool data in there, like human mobility data and spend data. So I definitely recommend there's a public-facing version of this. Go and take a look. Thirdly, building, visualizing, and sharing data and maps. So Carmen's going to be showing you more of this in a second, so I don't want to go into this in too much detail. But we have a really fantastic cloud-native visualization platform called CARTO Builder, where you can do in-app analysis with SQL. There's also no-code and low-code options available, so you don't need GIS or data science experience necessarily to be able to do this analysis and create these amazing visualizations, and then share them across your team, but also externally or with the public. And fourthly, CARTO is all about helping our customers solve problems. So our analytics toolbox and Python-based CARTO frames functions help people make fast, automated, and iterative analysis. And really our MO is big data. So we try and make it as easy as possible for people to analyze these huge data sets that people are producing these days. And finally, the whole CARTO offering is really an end-to-end offering. So If you have an enterprise license, you get access to all that CARTO has available. There's no sort of modules and extensions, you get everything. So all of these things, plus our APIs, connectors, libraries, Python, SDKs, all of it's wrapped up into one package. So I think that's quite enough of me. And I'd like to now hand over to Carmen to talk through some demos.
Thank you, Helen. Let me share my screen.
Yes, okay, I'm out. Over to you.
Okay. Should be fine now, I believe. Okay. So thank you again, Helen. Before I start with the demo, I wanted to visualize here a summary about what Helen has introduced before. So in this figure, we can see the planning, optimization, and strategy part that Helen was talking about before, also the monitoring and management, but we wanted to introduce as well the rollout and deployment. As you know, the interconnection between all these parts is very important, and that's how CARTO can help, thanks to location intelligence. And with a single platform, you will be able to interconnect correctly all the different results from the different departments to be able to commit the service targets and provide good quality to the users. Some of the parts that we can handle in the different departments and actions, for example, in the rollout and deployment, we will be able to change the different results from your coverage maps, and also sharing them between different teams. And of course, something that we shouldn't forget is that this is all happening on the cloud. It's a cloud native tool, is directly connected with BigQuery. So all the changes that are done in the database will be visualized in the maps that we create with CARTO, and that will permit us to detect poorly performing areas, for example, in the monitoring part, and being able to enable optimized response to that. Okay, I think it's time to share and discuss about the CARTO platform. So this is the landing page of the workspace. On the left, we have different sections, and today we will focus on maps and workflows. Just let me show again the slides. So we will focus on the use case of network planning and strategy. And this is an exercise we will make to reply to the question of how many people are not covered by 5G in remote rural areas. We will reply to this question with two different options. So we will be using some Spatial SQL, and we will actually see the code. And the other option that is when you actually haven't used SQL before. So we have this no-code module that is called workflows. And it will be ready very soon in its beta version for any CARTO user. And of course, all the operation and analysis, spatial analysis that we are making, it will be visible in our builder map. Okay, so I come back to the demo, and we have the maps here and the workflows, and I will start first with yes, give me a second, with the CARTO builder. So here you can see our scenario that is happening in Canada, specifically in the north part of the Alberta province. And we are assuming that we have already deployed our 5G network in the most populated areas, but to commit with the service targets, we have to take care as well of the people that is in remote rural areas. And let's see if they are covered or not with our current 5G network. To do that, I have added some data sets that are actually in my connection with BigQuery that you can see here. So we have access to our BigQuery project and any data set that is available over there. And we will start with 3 data sets to do our spatial analysis. So we have the population with an open source map data. We have as well the remote areas that we have to consider, the administrative boundaries where our people living in remote areas that we have to check if they are covered or not. And we have as well an example of 5G network. That is the network that we have already deployed. Okay, so I'm going to make 2 analyses. Both of them will be done with a Spatial SQL, and I will show you later how this code looks like. Don't worry, I'm not going to code just during the webinar. So I will show you directly the results. And the first operation we are going to do is to enrich our remote areas here with the population information. And the result of this will look like this. Let me show you. You can see that it has a similar shape than the remote rural areas, but there are some parts that are not visible. And this is because we have also filtered the areas that have no population. So in this first analysis, we are getting and obtaining the rural remote areas that are populated. And the darker the blue is, it means that there are more people over there. And the lighter color is that we have less people over there. Okay, that is the first analysis. The second analysis that we're going to make is to check which part is actually covered, and we will check we will do this with the second operation. So what we are going to get is actually what is not matching our coverage. And as a result, we can see here the populated areas in these administrative boundaries that are not covered. I can show you the coverage again, and as you can see, all these areas are populated and they don't have any 5G coverage. So here we have the result of our solution, and we will be able to share it externally or internally as we wish, thanks to the sharing button here. In this case, I have selected public map, but you can share it with your colleagues as well. You also can check here different settings for the viewers. So this one is really nice, as with this selection, you will be sure that the viewer is gonna take the most updated data. Remember, everything is in BigQuery, so if the data set is changing, our map will get the latest updates. Okay, so I have copied the link, and then I'm gonna check how it looks like. So it looks a bit different than what I was showing before, because we only want them to have a look into the populated areas that are not covered. Okay, before I show you the workflows, I just wanted to show you how it looks like the SQL code that I used, which is not a lot of, this query is not very big, but anyway, if you don't want to check or you are not familiar with SQL, you will be able to use our workflows with no code to do exactly the same analysis. I come back to the workflows part, and I will open an empty one here. As you can see on the left, we have our connection to BigQuery, and we have also the different components that we will use to do the spatial operations. Let me show you how it works. So we are going to do exactly the same exercise than before. We are going to check for the tables that we were using So the population, we have also the remote rural areas and the 5G coverage example. You can see how nice it is to get the overview of the data when you click on the table, and you can get as well an overview of the map. And the first thing we are going to make is the an spatial filter to intersect the boundary of our remote rural areas with the population. So we connect it here. We also have to filter with the populated areas. Oops, I don't want to connect this one. I want to connect this one, and we will do population per down 0. And at the end of these components, we will get our remote rural areas with the population information. And then the result, we will intersect it with our 5G coverage. Okay, we connect it here. So at the end, we will have the information about the populated areas that are not covered. You can see that we have the possibility to check also the areas that are covered. In that case, we will use the match part, but as we are interested in the parts that are actually not intersecting, we select the unmatched part and we will save it in a table. Save as table. We have to put the information of our project and also the name of the table. And we connect it with a match, and this is ready to go. Okay, so this is taking around 2 minutes. To save time, I have already prepared my workflow ready, so it is exactly the same. And at the end, what we are getting is an overview of the result. It is also possible to send it with an email. So this is another component that could be possible to add it after with the table. It will save the table in a bucket, and then we will share the link in the email, and then we open Builder again. We can give a name to our map. We have here the not covered populated areas. We can also style it. For example, let's put it in red as the other one. We also can create a new widget with the information of the population. And let's give it a name. Population not covered. And here it is. So we arrive to the same solution, and we will be able to share it with the amount of population that you can see that is changing in the viewport to an external person. All right, so I hope you liked this part. I'm gonna change to the second part of the demo. Yeah, there's more to show. Let me come back to the introduction of it. Wrong button. Okay, so this is another module that is gonna appear soon in our CARTO Analytics toolbox for BigQuery to operate with raster data. And we think that is very important for the telco operation, because as you know, most of the results from your legacy radio planning tools They have a raster format. For example, the coverage predictions, they are in TIFF or map info format. And also you are working with digital elevation maps, clutter height maps, everything in raster, which is good for visualization, but in terms of analytics, it could be a problem, especially if we are handling big data. And so for that, with this new model, we will be able to have all the raster in spatial indexes. Let me show you how it looks like. So yeah, spatial indexes, we could make a new webinar of it. I will try to simplify it, and let's say it is a data structure that allows us to operate and access spatial data more efficiently than using the traditional geometries and geographics data types. So yeah, what you're seeing here on the right is the raster, and on the left we have the spatial indexes. Yes, this is not a coverage map. In that case, we could say that Mexico has the nicest 5G coverage map in North America. But actually, for today's demo, we are visualizing the day-met temperature in Celsius. And on the left side, we have our spatial index of about 0.85 square kilometers. And the right, it is 1 square kilometers pixel resolution. So if we are zooming in, you will see that all the information is being aggregated depending on the zoom level. And these all calculations are happening on the fly at the database level. Only the tiles that are being shown are computed. And this is really nice, not only for massive data visualization, but also because we can get all the benefits from the vector data. So it will be much easier to interact with external data sets and to enrich your predictions or to analyze any other data sets that you are using. Okay, so yeah, here we are seeing at the same time we are calculating the average temperature. All right, I hope you like it. So just to sum up, we have seen 2 different use cases. So for the analysis on 5G coverage and spatial analysis on populated areas in remote rural areas with both workflows, Spatial SQL Builder, and in here we are seeing how amazing are the spatial indexes. Hope you like it. Thank you.
Amazing. Thank you so much, Carmen. That was brilliant. I really liked seeing how in the first use case you showed us a really common telco problem, which is, or not problem, opportunity, which is where don't we have coverage and where are people affected by that? But then also showed us how you can really put that data in the hands of people who have the sort of authority or power to be able to actually fix those problems and exploit those opportunities. So that was fantastic. So we've got about 10-15 minutes until the end of this webinar. So we've got a few questions in the Q&A. Please do keep sending questions in and we'll start to go through them. So first of all, a question is, how do I connect my Google project in CARTO? Which is a really fantastic question. So thank you, anonymous attendee who sent that in. And I'm actually going to show you how you can do that with this unplanned live demo. So let me just share my screen. Entire screen. Perfect. Okay, so you should now be able to share my screen. And now we're here in my my CARTO workspace, which, as I said, this is unplanned. So this is very messy and you're seeing all my sort of untitled maps. But I just wanted to really quickly show you rather than just tell you how to connect to your Google Data Warehouse. So like Carmen showed us at the start of this webinar, there's a few different elements down here in your workspace that will be really helpful to you when you're going through and doing analysis. To be able to connect to your workspace, you need to click on Connections. And you can see here are all of my connections to lots of different data warehouses. You go add a new connection. You choose the connection you want, so Google BigQuery. Sign in with Google. Hope that you're not going to get two-factor verification while you're doing a demo. I didn't, fantastic. Type a name for your connection. So let's just call this demo. And then choose your project. And it's really that simple. So I'm going to choose CARTO marketing team. And then you just click connect. Wait a couple of seconds. And now you can see I've got that connection here. And then it's just as easy as like Carmen was showing you just now. You can really easily, when you're in your map, interact with that project. And we can see that here. So I'll just move to the Data Explorer quickly. So this is where you can see all of your different connections or your connections to our data observatory, which is that big data catalog that I spoke about earlier. So here you can see we've got our demo connection in here. You can see all of my different projects within here. Let's open up marketing team and we can see my data sets and we can just open a quick table. So this is Tim Hortons in Ontario's. So that's how easy it is to access and connect to your Google Cloud warehouse. So that demo on the fly actually completely worked. Fantastic. So that's that question sorted. Let's move on to the next one. Carmen, I think this is one for you. Can you give us more details about the population open source data sets? I think you're on mute.
I'm here, yeah. I will reply to this question, sharing my screen. Okay, yeah, sorry, I didn't give many details about this population map. It is an open source map that is actually available in our data observatory. So here you will see different premium providers and also open source data. So in this case, the population is coming from the World Pop map and it's 1 square kilometer, but you can get it also in 100 meters. Yeah, I mean, this is ready to be used and it is also connected to BigQuery. So open source and premium data source are available in the data observatory. Hope it is clear.
Yeah, absolutely. Thank you. And I think just building on that, so I mentioned earlier, we've got about 12,000 data sets in the Data Observatory, which you can take a look at. If you head over to carto.com, you can access our spatial data catalog through there and have a sort of route around and look at some samples. But there's loads of different demographic data sets on there. So Carmen showed World Pop data set, which is a really fantastic global resource. But we also have census data for most countries. And on top of just regular demographic data, so things like population counts and genders and age, we also have some really great geosegmentation data, which is a word I always struggled to say and I didn't get through it then quite. Geosegmentation data on our data observatory, which tells you things about sort of market trends that are really interesting to look at. So we even have a data set on there that tells you how likely people are to be vegans or how hipster people are. So there's loads of really quirky data sets on there as well. And there's a really great free data set on the Data Observatory called Internet User Profiles, which tells you people's internet behaviors at really small areas. And that's available for free for CARTO users. So I really recommend having a look at that. It's super interesting. So Charlie Yang, thank you. What's the source of the population data used in the demo? So the source, as Carmen said, is WorldPop, which is a really fantastic free global resource. But like I mentioned, there's lots of different, lots of different data available on there. So I hope that answers the Charlie and anonymous attendees' questions on population data. Carmen, another one for you that looks really interesting. What would this demo look like for a fiber network?
All right, fiber network. Well, actually, you can handle any different technology for your in CARTO. For example, for fiber network, we can perfectly represent the location of the fiber thanks to the lines geometry, and also use some of our analytics toolbox. I'm not sharing, right? Not yet. Maybe I can show you which models can help you with Just let me show my screen. Okay, yeah, so I wanted to show you this because for fiber networks, we have two models that can be interesting. So the routing one here that will permit to find the most optimal route for the fiber network expansion, and also the geocoding module that we have here will help to get all the geolocation information from the client's addresses. So yeah, I mean, we will be able to visualize the fiber network, and thanks to the analytics toolbox, will help to check how we can expand correctly this network.
Great, thank you. Carmen, can you just stay on that page for a second? Because one of our other questions was, aside from some of the things we talked about in this demo, what are some of the other analytical capabilities of CARTO that might be of interest to telcos, sorry. So you can see sort of the breadth of the analytics toolbox capabilities that we have here at CARTO in this diagram. So I think it's really important to note that what we're really doing is building on the core capabilities that Google BigQuery already has. There's some really fantastic geographic, geospatial elements of Google BigQuery and analytical capabilities, and we're trying to just really build on that and help people do even more advanced things. Would you be able to navigate to the statistics module for me, please, under SQL reference?
Yes.
Thank you very much. Look at this teamwork. So one of the things, there's loads and loads of different types of, loads of different toolboxes that you can see in here that we offer to people. We have some that are really specific to industries. So we have a retail module and a CPG module. We also have whole modules that deal with spatial indexes, which is what Carmen was dealing with at the end, and lots of just quite general geographic functions like creating buffers, which is creating sort of fixed distance rings around features. So you can use all sorts of combinations with that to basically do whatever analysis you want. But my favorite, which is why I've asked Carmen to navigate to this, is the statistics, which is another word I can't say, statistics module, which is all about, it's a sort of really data sciencey statistical element of our analytics toolbox, which really helps you get quantifiable insights from your data. So this includes, we've got a couple of different hotspot tools. So you might be able to say where you're having real hotspots or cold spots of infrastructure downtime, for example. We've got regression tools in here, so you can see where there are patterns between different data sets. So maybe where you have lots of customers and where you have lots of billboards for your marketing, or maybe the opposite, where you have very few customers but lots of billboards, so you can really evaluate how successful your campaign is. So there's loads and loads of different tools in here, and I really recommend, this is all public facing, so I really recommend you taking a look. This is all very, like you can see at the moment, quite SQL focused, but as time goes on, like I mentioned earlier, we're really committed to democratizing all of this analysis. So we're building these workflows that Carmen showed. We've got already some point and click tools within Builder. So there's no matter your skill set, there's a way of you being able to get these insights from CARTO. We've got a couple of minutes left, so let's see if we can fit in one last question. Let's just take a look. A couple more on population data. Okay, can we talk any more about spatial indexes, how they work, how they're different to sort of traditional geospatial layers? Carmen, would you like to take that, or I'm happy to?
Please go ahead.
Okay, if there's anything you want to add, just jump in and tell me to stop talking. So the way that spatial indexes work and how they're different to traditional geospatial layers is traditional geospatial layers work on something called a geometry, which is basically a really long line string that says what the feature type is. So that might be a point or a line or a polygon. And then it has a coordinate pair for every point that's a corner in that shape. So you can imagine that could be huge. It could be really, really long if you're looking at something like a state boundary or even like a census tract. That can be really, really long, which makes it very expensive to store and very slow to compute. The way that spatial indexes are different is they're basically global grid systems. So you can get them as sort of hexagons, which I believe, no, I don't think we're looking at here. You can get them as hexagons, you can get them as squares, different sort of geometry types, but they're basically different hierarchies, which is what you're seeing here. So you can get them really, really zoomed in, where they're about a few feet across one cell, up to being tens of kilometers across one cell. And the way that they work and how they're different to geometries is they're geolocated, so they're placed on the Earth using a string, so a sequence of numbers and letters that's normally about, I think, 20 characters long. And that's the real difference, because that makes it so much cheaper to store, much smaller to store in your Google BigQuery project, but also much, much quicker to do analysis with. So it means that you're really unlocking being able to do analysis with big geospatial data in a way that you can't really with traditional geometries, because it would take too long. Is that a good summary of spatial indexes, Carmen? Anything to add?
It's really good.
Oh, thank you very much. Okay, I think we have one final question, couple of final questions. So, does CARTO have a street address geolocation capability? Yes, we absolutely do. So when we took a look at the analytics toolbox earlier, sorry, I thought someone was coming to my meeting room. They must have heard that we were having great questions in here. We do, so in the analytics toolbox, which Carmen's kindly showing you now, in the LDS module, I believe, we have a geocoding capability. So you can plug in things like zip codes or addresses or street names and be able to geolocate those data sets. And final question, because we've got 1 minute left and I know I'll be in trouble if I go over. Can CARTO help telecom operators for operation and maintenance by integrated with OSS? Carmen, do you know much about that? I'm not sure I know what OSS is.
I think it can help, but it's a bit complicated to explain it in a minute. So maybe we can come back to this person with more information about it.
Yes, absolutely. That sounds great. So, Carmen, if you could stop sharing your screen for a second, just so I can share mine, just to conclude. I'm having trouble with my browser refusing to let me screen share. Carmen, would you mind sharing the final slide of our presentation, please?
Sure.
Thank you. Just the get in touch one.
Yeah.
Amazing, thank you. So like I just mentioned, I think that's going to bring us to the end of our webinar. Thank you all so much for coming, taking the time out of your days, listening in. I hope you all found something useful, interesting. I know I did, even though I've seen this before in our practices. It's always really exciting to see. If you have any more questions, and if you had a question that we didn't have time to get to, please do get in touch with us. So we've got both of our email addresses on here. You can find me on Twitter or Instagram at Helen Makes Maps as well. And yeah, thank you so much. Enjoy the rest of your day.
Thank you. Thank you, Helen. Thank you, everybody.